CRDTs are a technique that provides us with availability within our application. Now, again, this is something that is applied at the application level, not at the database level. There are databases that do support CRDTs. That's not what we're talking about here. We are talking about doing this in our code. And the reason that we do that is because it means that we're not limited by what our database can provide. It allows us to do something in our application that maybe our database wouldn't be able to handle. So conflict-free replicated data types, also known as CRDTs, are specially designed data types. They're highly available and they're eventually consistent. So we're not talking about strong consistency here. If you want strong consistency, you use a technique like sharding. Here we are aiming for availability. The data in this case is stored on multiple replicas. That's how we get the availability. If any given replica fails, we can always go to the other ones in order to get the information that we're looking for. Updates are applied on one replica and then they get asynchronously copied to the other ones. That's why it's eventually consistent, because the updates are copied asynchronously. Now, in order to do this, we need a way to take potentially conflicting states and merge them into a final state. So there is a merge operation that knows how to take potentially conflicting states and merge into the final state. So again, CRDTs are a solution for availability. If you look at our diagram here, you'll see that we have 3 replica lines. And you'll see that on the top line, we do an update. Now, in this case, we're using the max function as an example here because the max function is something that's very easy to merge. So in the uppercase, we start with 0, and then we want to apply an update, which will have the value of 1. Well, the max of 0 and 1, that's easy to figure out. That's 1. So we know that our new value would be 1. But at the same time, on the line immediately below, we had another update, which was going from 0 to 2. Now, again, very easy to figure out. The max of 0 and 2 is 2, so we can figure that out. But now we have a problem, and the problem is that replica 1, the yellow one, thinks the max value is 1. The middle replica, the red one, thinks the max value is 2, and the bottom replica thinks the max value is 0. So that's when the merge operations come in. On the top line, when we get a merge of the 2 coming up, now we need a max of 1 and 2. Again, that's easy to figure out. The answer is 2. Middle line, we get a max of 1 and 2. The answer is 2. And then the bottom line, we get the merges in a slightly different order. We get the 2 and then we get the 1. But eventually, we just figure out that the max of 2 and 1 is 2. Now, once all those merge operations happen, all of our lines are in agreement, and we are now in a consistent state. So you can see how that operates. There are 2 types of CRDTs. There are CVRDTs and CMRDTs. So CVRDTs are known as convergent replicated data types, and they copy state between the replicas. This is what requires a merge operation, and the merge operation needs to understand how to combine the 2 states. There are some criteria for the merge operation. It has to be commutative, which means it can be applied in any order. That's a mathematical term that you can look up if you want. It also has to be associative. That means it can be grouped in any order. And it has to be idempotent. That means that duplicate operations don't change the result. So if we get the same state twice, we need to end up with the same result. There's also commutative replicated data types, CMRDTs. These copy operations between replicas rather than state. So they copy, instead of copying the current state of the data, they copy the operations that led to that current state. We don't cover CMRDTs in this course. They're not supported by any of the Lightbend stack, at least not at the moment. So we'll move on and forget about those ones and only focus on the CVRDTs. So here's another simple example. This is actually one that is part of the ACA distributed data. Now this is called a G set. It's a specially designed data type again. It's a grow only set. That means you can add elements to it, but you can never remove elements from it. Sets of this type are very simple to merge. So you can see, again, we have 3 replicas. The top line gets a value of 1. The middle line gets a value of 2. Again, now we have a conflict. Top line thinks the set contains 1. The bottom line thinks it contains 2. We start merging operations, and so you can see that the 2 gets merged up to the 1. And now when you combine those, well, it's a set. So you just add the 2 to the set and you end up with a set of 1 and 2. Very easy to do. When the 2 merges down to the bottom, We didn't have anything at the bottom, so again, that's pretty easy. Just add the 2 to the set. Then we see at the bottom line, we added a 4. So now, again, we can just merge up. So the 4 merges up. In the middle line, we end up with 2 and 4. And then in the top line, we eventually end up with 1, 2, and 4. And you can see that as these merge operations propagate, we're eventually going to converge on a value of 1, 2, and 4 for all 3 lines. Grow-only sets are very easy to merge. It's a very simple operation. You just constantly add things to the set. If you have duplicates, you just eliminate the duplicates. That's easy to do with a set. So this G set is a specially designed data type that you will find in ACA distributed data, for example. In addition to sets, there's several other existing CRDT types, including registers, counters, sets, maps. So we have sets that you can add and remove from, for example. We have maps that you can do the same. Now, CRDT data types can also be nested to create complex structures. So you can have maps that contain counters, for example. You can also create new data types. So if you can define an appropriate merge operation, again, that merge operation has to be commutative, associative, and idempotent. If you can define that operation, then you can create your own data types. So these are some very basic examples of data types that you can use. You're welcome to look in the documentation for ACA distributed data to see all the different types that are available to you. So in the Lightbend ecosystem, CRDTs are implemented in ACA distributed data, and they implement only CVRDTs. We don't currently support CMRDTs. It supports the various data types that are already listed: counters, sets, maps, registers. There's links to the documentation here if you want to know more about them. But that gives you a basic introduction to the idea of CRDTs. And we are going to talk about some of the consequences of using CRDTs as well. We'll do that in a later section.